Okie dokie. Hi, everybody. So this is a makeup lecture to catch up on some of what we've missed and get us ready for the midterm. So I'm going to take a step back and go back to the beginning of pointers. I'll go through kind of the start of this really quickly, and then we will jump into a little bit of an introduction on decision and looping. I'll also be writing some code for everyone during this lecture, so this should be a good practice for everybody. And then we'll be back in person next week, thank goodness. Okay, so we've already talked about this. I think kind of I've addressed it quite a few times now in lecture, but a pointer variable is kind of the key to this lecture. And a pointer variable points to the memory address of another variable. So a pointer is a variable, it's holding a memory address, and it's holding the memory address of another variable. So the pointer variable is going to be tied to another variable that it is pointing to, and it's going to allow us to access and modify the contents of that variable that it's pointing to, that memory address that it's pointing to. So here you can see we've already talked about this. The declaration of an integer variable, a double variable, and then a declaration of a pointer. So an integer type pointer, a double type pointer, and we spoke about this already. The type of a pointer is going to be tied to the type of variable that it's pointing to. So for a pointer that points to an integer, we need an int type pointer, and then we use the star operator here to indicate to the computer that it's a pointer. So if I just call it int and I don't include the star, then when I fill it with an address is really just a number. It's an integer, right? So it'll just be treated as a number by the computer. It won't be treated as an address. So we have to tell the computer that we're giving it an address and that this is a pointer and it's going to point to that address. How do we fill up our pointer variables? Well, we use that address operator, the ampersand symbol. So here you can see in the last two lines of this code, into integer pointer, we are putting the address of the variable integer and the address of the variable real. And we've covered this already. So like I said, for declaring and initializing, honestly, the best way to do it, I find, is for the declarations, do them in the same line. So declare your type, your variable, and your pointer all in one line. And that, for readability, makes it really easy to see that the variable and the pointer are tied together. The other thing you can do is, so using PTR, so capital P, lowercase tr, to name your pointers. So if the variable name's integer, I'm going to call it integer pointer. If the variable is real, I'm going to call it real pointer. If the variable is car, I'm going to call it car pointer, so on and so forth. So just using PTR to help, again, us know that this is a pointer and it's tied to the variable named integer. And of course, like we said, that star operator in our declaration is going to tell the computer that it is a pointer. And here's the notes of what I've already said. Okay. So like I said, star in the pointer declaration tells the computer that this is a pointer. PTR is the naming convention we're going to use. Remember that we can have multiple pointers pointing to the same variable. We cannot point to a variable of a different type. This will cause an error. It won't be a fatal error, but it will be an error. And pointers point to nowhere until they've been initialized. So we declare a pointer, but until we initialize it, it's pointing to nowhere. Pointers in the previous slide, so just going back, those don't point to anything, right? So this is a declaration. We haven't initialized anything yet, so we've allocated memory for them, but we haven't put anything inside them. So currently, these are pointers that point to nothing. Okay, so same thing over again. We have our declarations of our variables and the pointers associated to those two variables. And then we have our variable declaration here. So integer and real are getting declared. And then finally, we have the declaration or the initialization, sorry, of our pointers. So integer pointer gets initialized using the address operator, and then the variable that we want to point to. Same thing for real pointer, we use the address operator, and then the name of the variable that we want to point to. Okay, so same thing again here, just showing the working memory as we declare and then initialize our variables. So integer pointer, then real pointer. And again, highlighting the use of the ampersand, that address operator, for the initialization of our pointers, right? So this is going to tell the computer, don't take real, the variable, take the address of real. So this is an address. And I'm just going quickly through this because we've covered it all already. And I just want to do a really quick review to remind everyone where we're at. This is the same thing. So talking again about declaring and initializing, a pointer can be assigned a value of 0 or null if we don't want to fill it yet. So null is a symbolic constant. So the same way that we declare symbolic constants in our code, the standard input-output header file has symbolic constants that are preset for us as well, and null is one of them. Null is just a symbolic constant. It has the value of 0. So we can fill with 0, we can fill with null if we don't want to fill with addresses, but we want to initialize the variables. So if you try to use a null pointer, so a pointer with a value of null assigned to it, the program will crash. It's a fatal error. Okay, so this is towards the end of what we were talking about last time. We were talking about dereferencing or indirection. So that's done with the star operator here, you can see. And so we use this operator when we are accessing, when we're declaring our pointer variables, but we're also going to use it when we want to fill the contents of an address. So here we have declared integer pointer. We've initialized integer pointer on this line, okay? And then so integer pointer is a pointer and it points to the address of integer. And so in order to modify the contents of the variable integer, I'm going to use my star operator, so star integer pointer, and I'm going to give the new value that I want the variable integer to hold. So when I'm saying this all in words, it sounds complicated, but we'll look at the programming model right away and it'll be much simpler. The point is, though, that if I use the star with the pointer, it's the same as assigning a new variable to the actual variable. So star integer pointer equals 7 is the same as just saying integer equals 7. I'm sure you're probably like, why would you want to use the pointer then? It seems like a lot more work and a lot more complicated. Well, it actually becomes really valuable when we're using functions, and you'll see that in the example I have for you today. Okay, so here, what happens is we, on our first line, declare a variable. So we declare integer and a pointer for integer, and our pointer and our variable are both int types. We fill in the value of integer. So 8 is going to be the value that we put into integer. That's fine, not too complicated. And then from there, what we're going to do is we're going to initialize our pointer variable. So here we're initializing our pointer. So integer pointer is equal to the address of integer. And then finally, what we're going to do is we're going to use our pointer to change the value of integer. So star integer pointer equals 7. So just walking through this again. Let's go back. So if we walk through the programming model, I'm just going to use some colors here. So when I declare integer, its value is unknown. Same thing for integer pointer. I declare it and its value is unknown. But then I'm going to assign a value to our variable integer. So I'm going to assign a value of 8 to integer. So when that happens, this occurs, okay? And then here you know as well, because I told you the address of the integer variable is 7,000, the address of the integer pointer variable is 4,000. So then when integer pointer is initialized to be the address of integer, that's when the address of integer, so this value, gets dropped into the integer pointer variable, okay? So I'm just going to map this over here so you can see what's happening. And then finally, so using the star operator, we're pointing to the address held in integer pointer, and that address is 7,000. So the address 7,000, the contents of that address are going to be changed to equal 7. So this is when, so this line is when we are assigning a new value to the contents of the address held in integer pointer. So integer pointer is the address 7,000. Where is 7,000 in the memory? 7,000 is over here. So the contents of 7,000 in memory are going to be changed to equal 7. Okay. And again, we've covered all of this already, so this should just be a review for everyone. Here's just some quick notes. So again, remember, indirection or dereferencing is the term we use for when we're using our star operator here. Okay. So here we declare a variable and we declare and initialize a variable A, and a pointer for A is initialized to the address of A. Same thing, declare a double B and a pointer for double B. Now, these declarations and initializations are correct. However, here, we cannot use the ampersand symbol on the left-hand side of the equal sign, okay? So this right here is a problem as well. Note there's no indirection on B pointer here. So just note that that's important as well. Here we have B pointer is equal to A. So B pointer is an address. A is a variable, an integer variable. We cannot have a non-address stored in an address, okay? Here, we're assigning an address into a dereferenced pointer. So dereferenced pointer, right? Star A pointer is the contents of the address stored in A. So this is really the same as saying A, whoopsies, let me just erase that. A equals B pointer, right? Because the dereferenced pointer is the contents of the address stored in the pointer. So that's going to be the contents of A. So here we're trying to assign a address into a non-address variable. Here, same thing. Star A pointer is the same as saying A equals, and we're storing the address of A, right? So ampersand is an address operator. So we're trying to store an address into a non-address spot in the memory. And then finally, the last one, So a pointer is going to be equal to the contents of B, right? So star B pointer is the same as saying B. So again, we have an address and we're trying to assign a double into that address, which we cannot do. So just be careful here because now the star operator has 3 distinct roles in C. We have it as a binary operator for multiplication. In a declaration, it identifies a pointer variable. And as a unary operator, it's used for dereferencing. So accessing the contents of a memory address stored in a pointer. Now, beware, this is our order of preference. I had a question last class. What is the order of precedence? Sorry, I think I called it something else there. Order of precedence tells us how the computer prioritizes operators. So the first thing it'll always prioritize is round brackets, square brackets, dot operators. Then it goes into this line, then it goes into this line, this line, this line, so on and so forth. And if you have multiple operators, then it just goes left to right. Or right to left, depending on what is going on, okay? So depending on what type of operator. Yeah, so then here, we're just doing some math with dereferenced pointers. So we have our declaration and initialization up top. C is equal to A times B, that's fine. 7 times 3, it's going to be 21, fine, not a big deal. C is equal to, okay, a pointer holds the address of A, and the star tells us we're going in and accessing the contents of that address, right? So this is the same as A here. Star B pointer is the same as B. So this multiplication again is going to be 7 times 3, right? Which is going to be 21. Here we're multiplying A times the contents of the address stored at B pointer, 21 again. And finally, we have the contents of A pointer. The contents of the address stored in A pointer. It's going to be the contents of A times B, 21 again. So this is just 4 different ways to write the same thing. And depending on what you're trying to accomplish, you might use one of these methods. So I'll let everyone go through this again. We covered it last time in class, but it is just showing arithmetic with dereference pointers. And so we have some declarations, initializations up top, and then some arithmetic happening here. Just note in this case, we still have to remember that if we have integers and doubles, they take up different amounts of space in the memory. So we need to notice when we're going to have loss of information, okay? So we upgrade everything on the right-hand side of the equation, but if we have a double on the right-hand side and an int on the left-hand side, it'll get downgraded, okay? From a double down to an int, so just beware. Pointers and arrays, okay, so this is close to where we ended off last time. An array variable name used without square brackets. I don't know why I have curly brackets there. I'll get rid of that. So that an array without square brackets beside it is a memory address, okay? So the name of an array variable points to a memory address, okay? So beware of this. Whereas all other variables, the variable name is just the name of the variable and it allows you to access the data stored in that variable. An array name, when you don't have the square brackets beside it, functions as an address, okay? So here, B without the square brackets is the address of the first element that is part of the B array that has been declared above, right? So here we don't need that address operator. Note when we have B with the square brackets beside it, here we're indicating that we're looking at the first element, right? So once we have the square brackets, B is no longer an address. So then we have to use the ampersand operator, the address operator, to access the address of the first element in B. So here also just note that B pointer 1, B pointer 2, same thing, right? So if I had written element 1 or 2 or whatever here, these would not be the same, okay? Because the elements are in the elements of B are stored contiguously. They each occupy space and memory. So this would be a few memory elements down the line from the address of the first element in B. Okay. So because this is fun, because the name of a array without the square brackets is an address, then when we create a pointer for an array, right? So I create B pointer 1 or B pointer 2, they're all pointing to the same address, then we can use square brackets with those pointers, right? To access the elements in the same way. So B square bracket 1 is the same as B pointer 1 square bracket 1 is the same as B pointer 2 square bracket 1. So this is kind of just a fun fact about arrays, but generally we wouldn't use pointers for arrays. Well, we are in that we're using the name of the array, right? But I wouldn't create like pointer variable for the array. I would just use the name of the array to manipulate it, unless maybe if I were passing information to a function or something like that. So we can modify and access an array using a pointer without the indirection / dereferencing operator, right? So just remember that. For arrays, you don't need that little star operator. Why is that? Again, it's because the array variable name without square brackets, so remember without our square brackets, is a pointer to the address of the first element in the array. Okay. So here again, let's say B is an int type array and it's got a size of 3. So you can see here. And then we're going to have a pointer that we create. So star B pointer. B or so B0 or B pointer 0. Okay. This is the kind of entire chunk of memory. However, if we printed these out, they would print out the first element in the memory tied to, oopsies, sorry, that's not right, because these aren't addresses. So these are referencing, sorry, these are referencing the entire contents of that first element in the array, right? Because we have our square brackets here. So because we have our square brackets, these aren't referring to addresses anymore. They're referring to the contents of the array. They're acting as regular variables. And the same, so B1 or with square brackets or B pointer 1 with square brackets, B2, B pointer 2, they're pointing to areas in the memory, not pointing, they're representing areas in the memory that have actual contents. So let's say I said B, just to clarify here, because I think I mixed up my words a bunch there. B1 is equal to, sorry, B0 is equal to 8. B1, let's put it equal to 7. And B2, let's put it equal to equals 3. Okay. Then if I use B0, what I'm talking about is the 8 stored at B0. Okay. The 8 is the integer held in the first element of the array B. Then if I'm talking about B square brackets 1, I'm talking about the 7, and 7 chills out here in the next 4 elements of memory. Or if I talk about b square bracket 2, talking about this value 3 that's hanging out in the next 4 elements of memory, okay? However, if I just use b without square brackets, then I'm pointing to this first element, okay, in the array. Same for b pointer. If I wanted to access the first element, so the address for b1, I would need to use my ampersand operator beside b square brackets 1, right? Like this. And so that would allow us to access 7014, that address, and the same for B2. Okay, so pointers and structures. So this will be good, and this is what we're going to do our example on, because last time I did some programming, a little coding with arrays and addresses. So this time we'll do structures and pointers. So let's imagine here we're going to define pointers for structure variables as well. So if I have a cube type structure that I defined already, and this is going to be the same example that we've always done, like in the previous lectures with the cube. So imagine it's the same structure definition where you have color, height, width, length, and those are the elements in your, or the parameters in your structure, okay? So in my main program, I'm going to define a cube type variable, cube1, and I'm going to define an address of a cube type variable, okay? And then cube pointer, my address, is going to be, my pointer variable is going to be equal to the address of cube1, so ampersand cube1, okay? And from here, right, so if I wanted to use an address to access the components of a variable, I use that dereferencing operator, right? So if I want to use, going back here, all the way back to here, yeah, okay. So if I want to access the contents of the address stored in a pointer, I use my dereferencing operator, right, my star. However, so how do I access the parameters stored inside my cube? So it's called the structure pointer operator, and it looks like a dash with an arrow. Oops, let me get rid of that. It's a dash with an arrow, and it is going to allow us to, from the structure pointer, access into the specific parameters stored in a given structure, just using that address. So it allows us to access the members of a structure, the parameters of a structure via the pointer. It's equivalent to using the structure variable name and the dot operator. And the arrow and the dot operator have the same precedence. So we'll talk about order of precedence in a minute. So here's an example. So we create cube variable, cube1, and we create a cube type pointer variable, cube pointer. We assign the address of cube1 into our cube pointer, okay? And then there's two options on how we want to initialize cube1. So we can initialize cube1 using the variable name, same as we always do with a dot operator, or we could initialize cube1 using its pointer. So instead we would use the pointer variable. So here we've got the address of cube1 is stored in the pointer, and then we're going into the member of the structure, color, and then filling it with a value, and then doing that again with height, with width, with length. So this is the same thing. We're just using it in one example, we're doing it with the variable name, and in the second example, we're doing it with the pointer, okay? And just note here that the order of precedence for the Sorry, I'm just making sure my code blocks is still active. The order of precedence for this arrow pointer, the structure pointer operator here, just note that it lands up high here. So it's right near the top. So this is going to be important when it comes to the use of the dereferencing or the address operator in functions, and you'll see that in our example today. Okay, so all this talk about addresses, why would we even want to use addresses? It's a lot of work, it's pretty complicated, and in our main program, it doesn't actually help us a lot. Well, for functions, addresses and pointers can allow us to pass large amounts of information and receive large amounts of information from functions without having to pass a million variables, right? So just as an example, rather than passing all of the components of an array, I can pass the name of an array, which is a pointer, and then I use that to access the elements of the array and edit them in my function, right? So a variable passed into a function is being moved into a local memory, and then it has to be sent back out of the function to make it back to the main program for those changes to cycle from the function back to the main program. However, if we send addresses, addresses allow us to manipulate the components of addresses, locations in the memory, right? And then when we manipulate the contents of those addresses, we don't have to pass information back anymore. We've made changes to the memory itself in our function. So that's why addresses, pointers can be really helpful for when we're working with functions. So if we want to access and edit the content of a variable in the main program, we can pass the address of the variable to the function, and then the function can use the address or the pointer to edit the contents of the variable. So there's an example in the Word document module that goes with this lecture on Brightspace. So there's an example here that you'll see, and then I'll show you an example as well today. So here you can see we've got the definition of our cube type structure up at the top, right? And then we declare a cube type variable. We're going to fill this cube type variable with information. We're going to flush the input output stream here, and then fill the rest of it. This probably should be up here, really, but it doesn't matter for this example. And then we're going to run two functions. We're going to run print1cube, which uses the cube1 variable. And we're going to run print2cube, which uses the address of the cube1 variable, okay? So let's look at the difference between the functions, okay? So this needs a, there's a mistake here. This needs an ampersand. Ampersand needs here. Ampersand needs to go here. Ampersand needs to go here, I believe. Okay, so for the first function, we're passing the cube1 variable to it, right? So we're just going to call it cube in our local function because we could pass any cube. We could pass cube1, cube2, cube3. So in the main program right now, we're sending cube1 in, but this is a generic function. It could take any cube variable. Okay, and this function is going to print the color of cube, right? So we have our conversion specifier, and then we have the variable name, and then we access the member color. Same thing, print height, version specifier, variable name, and then we have the member that we want to print out, height. Same thing, print width, version specifier, variable name, dot width member. Finally, print length, conversion specifier, variable name, dot length member. Okay. So if instead we passed the address of our cube variable, okay, actually color here, then what would happen is we would use the pointer variable, and then we would use the structure operator. So remember, if we go back here, structure pointer operator, that arrow, so structure pointer operator, we use that, and we're going to go from that address, we're going to point into this member, okay, color, and that's what's going to get printed out. Now, note here that these are, so there's like a referencing or a precedence situation happening here. So if the structure pointer operator gets treated first. So this gets done first. Oh, no. 1 second. This is all good here. So this action gets done first. So we have the pointer for the structure, and then we go in and we access this member, okay? And then all together it gets printed back out on the screen. So note that that is what's happening here. When you are assigning values, you point in, okay? So if this were a scanf function, then you point in to your member, and then you would need to add the address operator on the outside. But we don't need that here because we're printing, not reading. And you'll see it in a minute when I show you the example. Okay, so here, same thing. We just use the structure pointer operator instead of the dot operator because we're working with pointers. Okay. So why would we send a memory address to a function? We would do that if we need to return multiple values, because in C you can only return one value from a function. We might do it if we are doing calculations in the function as well that are necessary for the main program. So if we're bundling up a set of calculations that needs to be done that will edit the values of variables, rather than sending those variables in, bringing them back to the main program and like overwriting data, we would instead just send pointers and manipulate them inside the function. Okay, so it could also be accomplished by returning a structure or an array depending on the data type and the organization data. However, in many cases, the address operator is going to be your best friend to do this, or sorry, the pointer is going to be your best friend to do this rather than sending structures and arrays back. So just as an example here, we're passing a 1D array to a function, okay? So you use the name of the array without the square brackets in the main program to pass the address of the first element of that array, right? So we create here and initialize. So we declare and initialize an array temp. It's going to be int type. It's got 5 elements, and we're just going to initialize them to all be 0. And then we're going to send temp into our function, okay? So remember, the name of an array is the same as the pointer to the first element in that array. So it's the same as passing an address. So if we manipulate the contents of the array and the function using temp, then these changes will remain in memory. These changes are being made to memory. So the contents of the memory elements that hold the temp array. So they will remain when we return to the main program, and we don't have to pass anything back. Okay. So if we send an address to a function, we have to specify a pointer in the parameter list of the function there's a couple different ways to do this. So this is the function definition here, right? So this isn't the call to the function, it's the function definition. So here you can see the way that we're telling the function that it's receiving a pointer is either by using empty square brackets with a value in them, or that pointer operator, the dereferencing operator, beside the name of the variable. Okay, so all of these indicate a pointer is coming, an array pointer specifically. Okay. So note that if this were just a pointer to an integer or double, we would not use these brackets, and we would instead just use that star operator. Okay, but right now we're talking about arrays specifically. So all of these tell the function it's receiving an address. If you give a value in brackets for a 1D array coming to your function, the computer ignores it. So you can put a value in there if you want to, just for yourself, but just know that the computer is ignoring this number. So the function prototype has to also specify that an address is being received in the same way. So just note, function definition and the function prototype need to indicate that this is a address, it's a pointer coming to the function. Now, if we're thinking of a 2D array and we want to pass the 2D array, remember the organization of the 2D array from the previous lecture. We're going to use the name of the array again, so we can use the name of the array without brackets in the main program when we're passing it. Same thing. Doesn't matter if it's 1D or 2D in the main program, we will be the name of that variable, the name of that array is pointing to the first element in the array. It's a pointer, as long as we're using it without square brackets. Okay. So here we initialize an array temp. It's 3 by 4, 3 rows, 4 columns. We're going to initialize the whole thing to 0. It holds integers, and we're going to pass the name of the array. So that's the pointer to the first memory address in the array to a function. Now, we have to tell the function that it is receiving an address again. However, things are slightly different with the 2D array. So in the function prototype and in the function definition, this time we're going to include 2 sets of square brackets. Okay, so we can have an empty one and one with the correct dimension in it. So empty for row, correct for column, or we can include the correct dimensions here. Okay. So we can also use the dereferencing or indirection operator. However, that's not a good programming practice for 2D arrays. So for these, you're really going to want to use those 2 square brackets, and you have to make sure that the number of columns is indicated. Okay. The function needs this information. Now, if you give a number of rows here, so right here, if I give this value 3, the computer is ignoring it anyway. So like, if you want to include it for function readability, which is what I do, then please do that. But otherwise, you don't need to include it, but you do need this value for the number of columns. Okay. We're going to cover this topic and then we'll do an example, and then that'll be it for today. So final thing I wanted to talk about really quickly is the character string library. And so this is something I'm going to ask you all to go look at on your own. So it's a set of standard functions for use with characters and strings. The big thing that you really you get out of this at this level is reading and writing strings rather than just characters. And the length of a string. So being a function that allows us to measure the length of a string. So The header file for manipulating single characters is ctype.h. Header file for manipulating strings is string.h. And then our standard library that we've seen before converts digits to integers or reals. Okay. This is a set of functions that you might find in the ctype library. So notice a lot of these are like, is alpha, is digit, is it a letter or a character? And so these are kind of check functions. So it's when I don't know if my variable is receiving the right type of input. So this is something we might use as a control in case somebody's inputting the wrong type of data in like the scanf function. We might like add this to make sure that our values are correct, or we might use it for decision making or controlling loops, which we're going to talk about a little bit later. So the string header file, the big one here is the string length function. So telling us the length of a string, which doesn't sound very important, but it's actually really useful. It allows us to like pre-allocate memory. So if I start off with a string or I take an input from a user, I can look at what's actually inside of it and start to understand like how much memory I actually need for a variable. So as well, yeah, string copy, so copying the contents of one string to another string. And then this function string cat is usually for concatenation, so we're smushing two strings together. So these are all useful functions when you get into taking a lot of like user input, especially when you're working with characters and strings. And then our standard library, we've seen this before, but we're just talking about a few more functions. I don't think you would need many of these right now, but I do encourage you to go look at them just because they'll help you expand your understanding of C. Okay, and then finally, so right now, we're using scanf to read in all of our data. However, we can use string-specific functions to read in strings of characters or arrays of characters as well. So getS is the read-in function for reading a whole string in. PutS is a print function, so it's printf. And it's going to put a string out onto the computer. So I might use this like if printf is allowing me to like add in my conversion specifiers and to do all sorts of stuff. But if I don't need like a more versatile function, I might stick with putS or getS. Okay, and then there's some examples that are available to you all that talk a lot about what we already did today. And then what I'm going to do now is share my screen, and we're going to do a little discard. We're going to do a little example here. So stop sharing. Now I will pull this up and pull this up. Okay. So I'm just going to share the screen again. Okay, so put this over here, put this over here, and then share this. Okay, perfect. So you can see here I've got my code blocks, and I am going to start a new file, and I will save it. Burp, burp, burp. So I'm not going to save this in the project I was working on. I'll put it over here. Yeah. So car struct example is what I will call it. Okay. So I kind of wanted to walk through a little bit of the use of addresses with structures. And then I also wanted to talk a little bit about like when deciding when a function is useful or necessary. Okay, so I'll begin my code by including my standard input output library, and I'll include my standard library of functions as well, but I don't think I'm going to need it here. Okay, and then so what I want to do here is I'm thinking about buying a new car. Okay. And so I've got my current car, but I'm going to look at a bunch of different cars, and I want to store the information that I get on all these cars. So thinking about kind of a good way to store all this data, like what are some basic things I might want to know about a car I might buy? So I might want to know the make, the model. Let's say I'm buying a used car, the mileage on the car. I care about the color of the car, so I'm gonna want to know that too. And then let's say how many cylinders it has. Okay, and whether there's any damage. Okay, so there's about 5, 6 things. So make, model, color, mileage, and cylinders and damage. So 6 things that we've got there. So what would these look like as variables if I wanted to store them? So make and model would be strings, right? Color could be a character or a string. The mileage is going to be, let's say it's an integer. Let's assume that cars aren't as precise as floats or doubles. And then the number of cylinders in the engine, that's going to be an integer as well, because you can't have 0.5 of a cylinder. Okay, so what I'm going to do here is I know that I have these different variables that I want to think about, and I know that they're going to be different types of variables. So what is a way to store different types of variables all together, knowing that maybe I might want to look at like 5, 10, 15, 20 cars, right, that I might be considering. Then I might need like a variable that can store like, let's say 20 or 30 different makes, 20 or 30 different models, and they all need to be associated with each other. And this is where a structure variable would come in very handy. So I'm going to declare or define a structure. Okay, so I'm going to define struct type to hold car data on used cars. Okay. And so this is going to be really simple. It's not necessarily all the information I would normally want, but we'll start with this. So I use my standard definition syntax for a structure, right? So type def, it's going to be a struct. And then underneath, I'm going to include the variables. So I'm going to declare a make variable. I'll give it a length of 20, a model variable, length of 20, a color variable, length, whoopsies. And just again, like 20 is just the random number that I've decided on. Like it's a character array. It's an array. It's a string of characters. So we need to make sure that there's going to be enough space for the longest variable name that I might want to include. I'm going to include an integer variable for mileage, and I'm going to include an integer variable for whether there's damage to the car or not, right? And here I'll give a little more information. 1 is for yes, so 1 is true, 0 for no. So either there is or is not damage to the variable. And then finally, I'm going to name the type of variable. So these are all going to be car type variables, and note that I used capital letters to define this variable type here. Okay. So this is going to be the structure type that I'm going to work with in this program that I'm writing. I'll just save everything really quickly. So then I'm going to have my main program. So void main empty round brackets. here. I've got my curly brackets. And now what might I want to do with my function? Okay, so, or my main program. So what do I actually want to do here? Well, the first thing I might want to do is to declare a car, right? So declare a car type variable. Good enough. And so I'm going to start off with the car I currently have. So we're going to call this, sorry, I'm double checking my notes to make sure that I'm using the same syntax so that when I give you the code, it won't confuse you guys. So car type structure variable, I'm going to declare it. It's going to be called car1. Okay. And then now what I want to do is I want to allow the user, me, to input data into the car type variable. Okay, so what I'm going to do is read in data from a, sorry, here, let's do it this way. Read data into a car type variable, car1. So we're going to fill in car1. So first thing I'm going to do is I'm going to give the user a prompt. So what is the make of the car? Okay. And then I will read in, so scanf. And so make is a character string or a character array. So I'm going to use the %s conversion specifier. And then for the syntax here, remember for scanf, we read into an address. So it's going to go into the address of car1.make. Okay, so it's the first parameter in my structure. So from here, I'm just going to put new line characters so that I can visually like read easily. And then we're going to do this again for all the different variables, right? So what I'm going to do is I'm going to copy this, right? And so whenever I'm writing code, if I can copy paste, that's amazing. So what is the make of the car? The next thing is what is the model of the car? So model is also a character string. So all I need to change here is that we're reading into data into the address of car1.model, okay? The model parameter of car1. Do this again. So make model, what is the color? Just color of the car. So same thing, it's going to be character string again, and color is what we're reading into. So that's the parameter that we're filling. So what is the color of the car? And then from here, the next thing is mileage. So what is the mileage? Mileage on the car. And so I'm going to use the %i symbol conversion specifier here, and we're going to replace this with mileage because we're reading in an integer. And then finally, what is there damage to the car? There damage to the car. And again, imagine I was writing this for somebody else. So 1 is yes, 0 is okay. And then here, this will be an integer as well, car1 dot damage. Okay, so this is going to be the code that allows me to read in data into my car1 variable. Okay, so I'm going to run this code here, see if there's any errors or if I made any mistakes. So doesn't seem to be any fatal errors here. Okay, so what does it make of the car? So I'm going to start off by putting the information on my current car. So currently I have a Mazda. What is the model of my car? It's a Mazda 2. Mazda 2. What is the color of my car? My car is green. What is the mileage on my car? It's around 175,000 here. And is there damage to the car? Yes, of course. It's a used car and it's old. Okay, perfect. So process returned, nothing problematic here. Okay, so I just read in a bunch of information, but I don't know like how this was stored. So was it stored? Was it stored correctly? Did I make any mistakes in my code? So how would I double check this? Well, I would go and print this data back out. Okay, so I'm going to close this. And I'm going to add in print data and from car type variable car1 out to screen. Okay, so now I'm going to print all of this data back out. Okay, so I am going to do this using the printf function here. So the details data for the previously input car is, and I'll put \n here. We'll do it like this. And then I'll print out each variable one at a time. So make, and this will be a %s conversion specifier here. And then after that, I'm missing my semicolon here. So after that, we'll include car1 dot make, right? Because we're printing out, so we don't need the address operator anymore. So make, and then I'll repeat this for model, color, mileage, and damage. Okay, so model goes next. Model, make, model, color, mileage, and damage. And I'll adjust my printf functions. So model is this, color is this, mileage is this, damage. I'll call this damage status, is what I'll call it. This is going to be, and so remember our conversion specifiers need to be correct. So these are integers. We'll use %d for the printf function as well, just for readability. I'm going to include a couple new line symbols here just to make sure there's lots of space and the output is super readable. Okay, so now I have some code that reads in data on the car I might want to buy and then prints it back out to show me exactly what I put in. So I have a record of it, right? I can double check that my code is working, and whenever I want to see this, I can just run the code. Okay, I'm gonna run this function, or sorry, run this program. Let's make a car. Like I said, we had a Mazda. It's a Mazda 2. It's green. Has a bajillion kilometers on it. And yes, there's damage to the car. Okay, so the data for the previously input car is, it is a Mazda 2, green, 175,000 kilometers, and damage status. Yes, there's damage. No issues here. This is amazing, right? Okay, this is great. So, perfect. I entered one car and I printed out one car. But, you know, what if I want to enter 10 cars? Print out 10 cars. Enter 20 cars. Print out 20 cars. So right now I only have one car variable, and I'm going to have to copy and paste these lines of code. I'm going to have to change car1 to car2. I'm going to have to declare all these variables. So what we're going to do is we are going to create some functions here. Okay. So I'm going to create a function for reading in car data, and then I'm going to create a function for printing out car data. So just starting off with the reading in function. First thing we want to do is create a prototype, or we could start with a function definition, or we could start with the call. So you can kind of, it depends on how you think, determines where you're going to want to start with your function and writing your function. So for me, I'm going to try to build the function out in my head first. And so I'm going to think about, like, what do I need to send to a function in order for it to fill in my variable. And remember, we're talking about pointers today, so I'm obviously going to want to send a pointer. So I'm going to create a function, and I'll start off with, I think, my function call. So I'm going to call my function fillCar, and I'm going to send the address of my car variable, car1, so address of car1 to my function, and then my function is going to fill in my car variable. Okay, so just based on this function call here, and I'm going to comment it, call a function to read in data to car type structure variable. Okay. So I'm going to call a function to read in data into this car type structure variable. Okay. So probably the next thing I'm going to write is my function prototype. This is just kind of, for me, how I'm thinking through this. And I just want to use the right syntax here. So I'm going to comment this. This is going to be the function prototype for a function to read in data to car type structure variables. Okay. So this function is going to be a void type. It's going to be called fillCar, like I said, and it's going to receive car type variables, but it's actually going to be receiving the address for a car type variable. Okay. So this is my function prototype, and this is how we kind of show that it's receiving a car type pointer variable. Okay, so a variable that points to a car type structure. And then now I'm going to go down to my underneath my main program, and I'm going to, right here, you'll see I copy pasted the function prototype, and that's because it's very similar to what I'm going to need in order to write my function, right? So I need the type of function in the function definition, I need the name of the function, and then here I need to tell the function that it is receiving a car type variable. It's a pointer. I'm going to give it a name. So whatever I send to it, I'm just going to call it car pointer. Okay, and then I need to write some code. So going back up here, what am I sending to fillCar? It's the address of car1, and we call that car pointer, okay, when it comes to us. And so this function, fillCar, is going to complete the task that I had here before, okay? So it's going to fill in the make of the car, the model of the car, the color of the car, the mileage of the car, and so on and so forth, right? So I'm going to copy and paste this and use this as the building blocks for my function. So there's going to have to be changes, right? Because here we were working with the car1 variable, and now we're going to be working with so this is a pointer variable, car type pointer. Sorry, it's a car type structure variable, not a pointer. And instead, now I'm sending a pointer. I'm sending an address. So we're going to have to change from the dot operator to the structure pointer operator. Okay. So as well, the variable name is different, right? So here, car pointer is what we're using. So what is the make of the car? Car pointer. And we're going to point to the make member of the address passed to the function. And this is where this ampersand is important, right? So if we were assigning values to the car variable here. Actually, that's not a good way to explain it. Actually, I don't think this needs much explanation. This is pretty good. So we have our pointer, car pointer. We point to the member operator, or sorry, the make operator. Sorry. We have our car pointer variable. We use the structure pointer to point to the make member. Okay. And then from there, we apply the address. So we want the address of the make member of whatever car variable was passed to us. Okay, car pointer variable. So here we're gonna what is the make of the car? Now %s ampersand car pointer, structure pointer operator, point to the make member. Same thing again. So car1 isn't what we have a car pointer. So we need to update the dot operator to be a structure pointer operator. And I'm just gonna repeat this all the way down. Okay, perfect. So now you'll see I've updated this function, and this function works with a pointer, a car type structure pointer, and it uses the structure pointer operator to assign values to the members of whatever address we send to it. Okay, so I'm going to get rid of this assignment or read in section of my code because I don't need it anymore. It all runs when I use this fill car function. So whenever I use fill car, then I run this function called fill car, and we fill in the components of the structure, the members of the structure. And we do that using the addresses. So we don't have to worry about passing data back to the main program, okay? So let's run this program again. So build and run. See if we have any errors here. Okay, so look, you'll see in our code, right, in the main program, we don't ask anymore what is the make of the car, right? So all of this is happening inside of our function now. So what is the make of the car? We're inside the function. So what we're going to do is we're going to enter data and check that when we use these structure pointers operators with the structure address, that it is actually filling in the data. Okay. So what is the make of the car? We said I had a Mazda. It was a Mazda 2. It was green. The mileage on it was around 172,000 kilometers. And yes, there's damage to the car. Okay. And so data for the previously input car, Mazda 2, green, 172,000, damage status, yes, there's damage, and everything is good, no issues. Amazing. So from here, let's imagine, right? So I wrote this function because I know that I'm going to want to make a bunch of car variables, right? I'm going to want car 1, car 2, car 3, car 4, so on and so forth. If I'm going to be printing out car data for all my variables as well, then I probably want to make a print function for the car variable as well. So let's do that too, okay? So let's start with a function call here. So I'm going to call a function to print out data from car type structure variable. Okay. And so we're going to call this print car. And again, I'm going to work with the address, right? Rather than sending in the actual variable, I'm just going to send the address. It's just as an example, okay? So then I'm going to write my prototype for my function, right? So this is a function prototype for a function to print out data from car type structure variables. And the name of the function is print car. It's taking in a car type variable again. That is a pointer, okay? And it's a void type function, so it's not returning anything to the main program, okay? And then I'm gonna copy and paste my function prototype. Oh yeah, here, this is function definition. Comments, that makes more sense. Okay, and I'm gonna print this down here. And so remember how we did up here, we need to name the pointer variable that we're sending in. So I'm gonna call it car pointer again, because it's the same type of variable. And then I'm going to copy paste this from my main program. So I'm actually gonna cut it out because I don't need it anymore, right? Because print car is gonna do all the printing, so I don't need it in my main program. So now, copy pasted this. However, because of the fact that I'm now sending the address to my pointer, not the actual pointer variable into my program, my function, I need to update, right? So here, printf, the make, so car1 doesn't exist in this function. We have car pointer, and that needs a structure pointer operator. So that's what I'm going to replace with here. Same thing here, do it again, and do it again, and do it again, okay? And then now this function should, assuming I didn't make any errors, should print out all the data on my car, okay? And so let's just do build and run. Oh, I've got an error here. So what's my error? Give you guys a minute to figure it out. Okay, so you'll notice there's no semicolon here. There is a semicolon here. So this is the risk of like copy pasting things across your program, is sometimes you'll end up with errors from like the line you copy pasted because that line wasn't meant to do exactly what you want. So you have to pay attention and make sure you're always updating everything. Okay, let's try one more time, build and run. Okay, so what is the make of the car? Mazda, it's a Mazda 2, it's green. Mileage was around 175,000. Is there damage to the car? Yes. Okay, data for the previously input car is it's a Mazda 2, it's green, 175,000 kilometers. Damage status is yes, it has damage. Okay, so it looks like the function is working pretty well here. So my fill car function is working, my print car function is working. And so now what I want to do is I'm going to read in. So I started off with the car that I have, right? And the first car now that I look at, so I want to include that data too, right? So I'm just going to update here. So I'm going to run these lines back to back. So first, and I'm just going to change the commenting so that the code's a little cleaner. Okay. So here, sorry about that. So here I'm going to comment that read in and print out data from first car, and then I'm going to include a second car. Okay, so car 2. Okay, so I'll do this again. I'm going to copy paste, and you'll notice like whenever I can, when I'm writing code, I'm always going to use copy paste. So I've declared this variable to and I'm going to run this function now. Okay, so instead of having to like copy paste all those lines of code for car 1, copy them, paste them, change car 1 to car 2 and all my printing and all my reading in. Now, all I had to do was copy paste 3 lines, which is a lot easier. So let's run this now. See what happens. Okay, what is the make of the car? So my first car was the Mazda. It's a Mazda 2. It's green. The kilometers on it are around 175. And yes, there's damage to the car. Amazing. Perfect. And then you'll see here, okay, so prints back out my data, and then it asks me again, what is the make of the car? Okay, so you'll see the readability is not great. I forgot to put some new lines in here, but we're still, everything's working the way it should, right? So now I have my next car variable. This is asking about car 2. So car 2, let's say it's the first car that I went and looked at. So I went and looked at a Kia. It was a Rio. It's a white SUV. Mileage on it was around 60,000. Is there damage to the car? No, obviously, or I wouldn't want to buy it. Okay, so data gets printed out. So we have Kia Rio white 60,000, no damage. Amazing, so good, right? Things are looking great. So now what are the fixes I want to make here? Well, I'm going to fix my print out function. I think I'm going to add a few new lines to it. The end, just so that it like looks nice and clean on the screen. And actually here, I think, no, this is good. Okay, all good. Okay, and then let's add in, let's do this with a third car, let's say. Okay, so let's go with car 3. I'm running out of cars too. Oh, did I forget like cylinders here? Oh, I forgot about cylinders. Oh, whatever. Okay, perfect. So I'm going to add car 3. And yeah, you'll see all I had to do there was just to show you again, delete. I just took my previous line, copy pasted it. And then I changed car 2 to car 3, car 3, car 3. Okay. And so now run it again. So we'll do this one more time. It's probably getting boring for everyone, but it's good practice. Mazda 2, green, 175,000. Yes, there's damage to the car. Perfect. Now, what's the make of the next car? We said it was Kia Rio. It's white. It is 60,000. And is there damage to the car? No. Okay, what is the make of the next one? Let's say it's a Toyota Corolla. I think it's Corolla. Color of the car, let's say it's blue. What's the mileage on the car? Let's say 37,000 kilometers. And is there damage to the car? No. Okay, perfect. So now I've got 3 cars stored here. There's car 1, car 2, car 3. And you'll notice that like I seem to be creating a lot of car type structure variables. I wonder if perhaps we could store these as instead of them being a single structure variable, so car 1, car 2, car 3, maybe we could think about storing an array of structures. So this is something that we talked about last time. So just to remind everyone, I think it was back here, arrays, yeah, okay, here. We talked about character string arrays here, and we talked about arrays of structure variables, okay? So in order to create an array of structure variables, right, when we do our declaration, we use our structure type, okay, the name of the variable, and then we use square brackets. So let's try this now, okay? In order to do that, right, when we create our initial variable, we would create cars, let's say 3. So we're going to create car type structure, but it's going to be an array of car type structures. We'll call it cars, and there's going to be 3 of them. Okay. And now, in order to fill the variable, right, instead of filling car 1, I'm going to take the address of cars, 0. Okay. And then I'm going to print out the address of cars 0. Then for this one, it'll be cars 1. And then we're going to print out cars 1. Okay. And then here, we're going to, whoopsies, mistake there, change this to cars 2. And here we'll go cars 2. Okay. And now we're going to be working with a variable called cars. It's an array of structures, and there's going to be 3 individual elements inside the structure. Each element is going to be a car type structure. So each element in cars is essentially like car 1, car 2, car 3. Okay. So let's, what else do we need to fix here? So now I don't need this line anymore, right? I don't need this line anymore, right? Because it's only one variable now, right? So let's start like this and see how the program works. I haven't made this edit yet, so we'll see if it runs an error or not. What is the name of the car? Mazda. It's Mazda 2. It's green. Mileage on the car is 175,000-ish. Okay. Looks like it worked fine. What is the make of the next car? Kia. It was a Rio. It was white. It had around 60,000 kilometers on it. No, there's no damage. Amazing. Next one, we said it was a Toyota Corolla. Can't spell Corolla to save my life. What's the color of the car? We said it was blue, and then mileage, I think it was like 25,000, and then no damage. Amazing. Everything is done. Perfect. So we went from what would have been quite a long main program with lots of different variables to we have one variable now. It's an array, a structure array, and we're able to fill and print out data from each of the elements in our structure array. Okay, so this is kind of a starting point, and it's building on what we're going to talk about next time, which will be decisions and looping. So I will put out another video, I think, to talk a little bit about that either on the weekend or I'll cover it on Tuesday. So I'll send an email once that's all done. And thank you everyone for watching this. I hope you all got something out of this. I know I rushed at the beginning, but that again is just because we've talked about pointers a lot already. So I really wanted to focus on getting an example in and just covering briefly like the 1D, 2D arrays. So looking forward to talking to everyone, and I'll send out an email and the link to this video later today. Thank you all.